All right. So those of you who did Ashley asked about the Vanderwaals equation for gas laws. That one was the ideal gas law that was correct. Remember, it had the funky pressure plus, what was it? I can't remember. It's A times N divided by V. And then it was like in the PV equals an RT, the V part was minus like N times V. You won't, that equation is, that's an equation more along the lines of relative, relationship-wise, how would the ideal gas law need to be correct? Not one that you're going to do an actual calculation. Okay? So more along the lines of why do we need to add to the volume? Why do we need to, subtract from volume? Why do we need to add to the pressure? And that's because of the ideal gases versus real gases, where real gases do have volume. Real gases do have intermolecular forces and change those values. Okay? Who else has questions? Look at the back of your periodic tables. You also have a copy of this in Drive. Okay, so if you look in the resources folder, you've got a copy of this as a PDF. So you'll see in the equations there where it says thermochemistry, I think that's the section, right? You get the Q equals MC delta T. You've got three total equations there that have that sum of, but we're only doing the delta H one, right? And that equation uses the enthalpies of formation. So if you look at that carefully, you've got it says the sum of the enthalpies of formation. It's got the delta H degree sign, little f. So remember, we had three flavors of Hess's law. System of equations, where you have multiple equations, you rearrange them to make one. You flip equations if need be. If you do that, what happens to the sign? Change the sign, opposite. So if it's positive, make it negative. If it's negative, make it positive. You multiply or divide those equations to make the coefficients correct, in which case you have to do the corresponding thing to the numerical value for the energy. So if you double the reaction, you need to double the energy value. Second flavor was using the enthalpies of formation. You would have to be given a table of those. Two possible questions would be, what is the enthalpy of the reaction? In which case you'd be given all of the enthalpies of formation and plug into that equation. Or you could be asked, what is the enthalpy of formation for this compound? Which you would be given the enthalpy for the reaction, and then find the enthalpy of formation for one of the variables.
The system of equations ones, you're given the enthalpies of formations for all of the equations that you did.
Okay, so they're not enthalpies of formation, they're enthalpies of the reaction.
Right.
So yes, you'd be given those values. Okay. The third flavor was using the bond enthalpies. Remember, I said I would give you the Lewis structure to work with in that case, like we did last time, where I had the reaction, but then I wrote out the Lewis structures for you. That way you know what kind of bonds and how many you're going to be dealing with. For the gases, that's under the solids, liquids, and gases section. And you're really only using what, the ideal gas law, which is at the top. Those first three equations are variations on stuff like Dalton's law of partial pressure is basically that's that P total equals PA, P plus PB plus PC. It's basically, if you have a mixture of gases, you just add all the pressures up individually to get what the total pressure is. The other one where you've got the P, what is it, PA equals P total times XA, that's your mole fraction. So you can use the fraction of moles. So if I had a gas and you had 50% of one gas and 50% of another gas, then the pressures of each of those would just be 50% of what the total pressure is. So if I had a mixture of two gases and the total pressure was 4 atmospheres and they were 50% each, the pressure of each would be 2 atmospheres. It's just proportional. Okay. I think that's all the equations. You've got the conversion from Kelvin to Celsius on there. I think that's it in terms of the equations that you would need to use.
What did you go over for the, like all the
Owls, I've given you those practice from the AP classroom, right? So, can you guys go back? Yeah, you guys can go back and look at them, but you've already answered it. But you can go back and look at them, right? Remember, you have those the sets that are due tonight for the AP classroom. I know that so those of you who haven't scored your Hess's Law quiz, do that. Submit it. Only 30% of you have done the enthalpy of formation quiz and the bond enthalpies quiz. Okay? Just giving you a heads up. Those are these three here are the ones that we're doing tonight. You have these that you can use for practice. Okay? Just do them. It's the multiple choice. I think I told you guys you can do the free response questions on your own. I'm not going to look at those. But these multiple choice questions here would be really good to look at in preparation. And we'll have, if we have time, we'll just have you guys work through some of those.
I can't score my Hess's Law quiz.
It says it's locked.
I finished it, and I went to complete it, and it just says awaiting scoring. Like, it's not showing up in my app.
Oh, I bet I have to, let me check something here. I wonder if I needed to check that you can score it. Edit. Edit. Update settings. Inmates, yep. I forgot to just select student score rule. Give it a couple of minutes. I think it takes time for the system to process. Let me check this one. Yeah. anybody else have any other questions before we do some more organized stuff as a class? Taylor?
How much of the stuff would you say is on like the gas stuff, like that?
I'm planning, you got my email about how devastating Friday is, right?
It could be more.
I'm planning on 25 questions, multiple choice.
For like the whole test?
For-
For
Well, then you'll do next week, cause Friday's screwed up. Next week you'll do the pre-response part, okay? It's not gonna be exactly a 50-50 split. You're gonna have, I think it's like maybe 10 and 15, 10 gas, 15 thermo. Okay? Ashley?
You agreed on an ABC, right?
Yeah, I described that in your course syllabus. So going into the test, I will already know if you miss this many questions, you're gonna get this score. And then for the free response, I scale it to 5 and then average the two together. Okay? Your goal is to miss as few questions as you can. That's what it boils down to. Okay? I'll plan on, the time limitation would be, there's 25 questions. I can't do the math in my head. 25 times 25. You'll have, I'll give you 40 minutes. Technically, it should be 37 and a half. That'd be a minute and a half per question, which is what you get on the AP exam when you take it May 1st, okay? Because you're gonna have 60 questions on May 1st, multiple choice, in 90 minutes. Okay, so I scale it that way. So those of you who like to stare at your multiple choice forever, those of you who like to ponder a question forever, skip that question and come back to it. Remember, the goal is to miss as few questions as possible or to get as many as you can correct. Right? So if there's a question you're not sure about, you read it and say, skip it, come back to it and save it for last. Because the odds are you're going to be spending a lot of time looking at a question you may not know how to answer or you may not be comfortable with, and wasting time on questions that you would be comfortable with and that you do know how to answer. Okay? Other questions? Yeah.
How is the response question part gonna be formatted? Like, is it gonna be much like the response questions
That you've seen, yeah, so it'd be parts A, B, C. I haven't decided definitely which questions to include yet, but you'll have like the gas law and the thermo, they'll kind of be combined together. So the gas law question that would require some thermo, or that may be required to calculate the thermo question, okay?
Would it be like similar to the one we did on the class?
Yeah, so where you got a set of questions, calculations, maybe a short answer, explanation, okay? I mean, the reason why I've assigned the AP classroom stuff is because that is the closest preparation to practice questions that you have. That's why I'm not doing, I mean, I have stuff, did I tell you guys, I told you guys I have stuff in Albert, but that's not my focus. Because those questions are hit and miss as to how good they represent the kind of question that you would have on the AP exam. Okay? Nothing like looking at recent history. This was last year's AP free response questions. Answer this one. I don't want to rush you, but most of you should have an answer for this by now. Who has an answer? Raise your hand if you've got an answer. Ready to go. Okay. I'm going to give you another minute. Well, I'm not going to. This is a question that doesn't require a lot of work to be shown, but I would like to see at least a little work, okay? To explain so that I would know and the scorers would know what reasoning you're doing. You're using. Darren, since you wanted to know whether your answer was right or wrong, let's see whether your answer is right or wrong. What'd you get?
3.6.
How did you get 3.6?
I multiplied the total pressure by moles of carbon dioxide.
Which was
3 over 10.
That's it. Okay? So I just got done telling you guys about the equation on your equation page, right? Your moles are proportional to your pressure. So if you got 30% of carbon monoxide, then 30% of the pressure is going to be carbon monoxide. Your total is 12. That's it. That's why I said, I don't want to rush you too much, but you probably should have had an answer, right? Because is that much to do? No, it's recognizing that you've got proportions there, okay? Questions?
They'd rather see that work or the ideal gas law.
How did you set up the ideal gas law?
You calculate the volume of the entire thing, and then
How?
10 moles times the gas constant times the temperature.
Did they give you a temperature?
No.
So you just made one up?
No, isn't the constant 273?
Actually, you could use any temperature. 273 is a good one. So you had 10 times, would you use 8.314 or 0.08206?
That one.
You use 273?
Yeah.
That's fine. Here's the thing, they don't give you a temperature. It doesn't matter what the temperature is, right? In the end, things are gonna be proportional. As long as you use the same temperature for both calculations, right? So, you're looking for the pressure, what volume did you use? Because they don't give you the volume, do they?
No, the pressure's 12.
Oh, 12. And you found the volume. You did that? And then you use that volume and you plugged into X times V is equal to 3.
X times. Oh yeah.
P times V, whatever that happened to be, right? And you did 3 times 0.0206 times 273. Same, that's the same as this. Because it's just proportional. But yes, there's more than one way to solve the problem. Okay? Offhand, I can't think of any others that would be obvious. Okay? Questions? Okay, next question. Do I need to make that bigger?
Yes.
Is that better?
Yeah.
probably should be close to finishing this question up. Who's got it? Nasser, tell me what to write.
1.5 G times 1 mole, 120.36 grams. Oh my bad, 150. What? No.
15 grams.
Oh, 15 grams, not 1.5. Equals
Equals. Alright, I'll go with it.
0.1246 moles, and then times 32.6 up, oh yeah, and then 1 mole on the bottom equals
Is that joules or kilojoules?
oh my.
Is that joules or kilojoules?
I'll be a bit wrong here.
Did you use 1.5 and 32.6?
No.
He did say 32.6, did he not?
Yeah.
Okay.
I think it's
It's point
4.04.
4.04? Confirm or deny? Deny?
It's close enough.
4 point what? Now, quick note. That's the correct number of significant digits. This is a question. So on the AP exam, I'll point it out or maybe circle it. But on the AP exam, I'm not going to take off unless, if it has 5 significant digits, you gave me 1, then I'll probably make a stink about it, okay? But you would have one way, 1 more or 1 less. So this would be acceptable, is it 4.10 or 4.09 something?
4.1.
1001.
Those two are okay. This is the correct number of significant digits. Because that's got 3, that's got 5, that's got 3. Okay?
So would I like be taking points off for 4.04?
Yeah, because that's not right.
It's so close.
It was the one.
So, Nasser, did you write 32.9 or did you write 32.6 on your board?
Yeah.
You did?
Yeah.
Now, I don't know. I've never graded. I have no desire to grade. Grading is one of the most painful things I do as part of my job. I hate it. Okay? But I will do my darndest to make sure I score yours right. But here's the thing. The couple of workshops I've gone to for AP chemistry, they have said they want to give points for people showing that they know what they're doing. And if they went and looked at your work and saw that you put a 6 there instead of a 9, they're probably going to give you the full credit for that. Okay? Even though that's the wrong answer, you have set, if this is the work you had, that you had 6, you're showing everything, they can see that you made that transposition of that 6 and 9, you've got it. I would give it to you, okay? I'd probably circle and say, watch what you're doing, okay? But you shown properly how to do it. Now, why did you do this?
I don't know.
Why? Just make it one continual, that times that, okay? I have a question for you. Did you type in that .0 something something, or did you arrow up and select it?
No, I did not retype it.
Okay, good. Good. Okay. Questions on this one? So you guys understand again why I was I'm not rushing you. I'm just saying what you should expect in terms of expediency for actually answering the questions, okay? All right.
give you a question, but they don't ask for a unit of, say, joules or kilojoules equal either one?
No, because they don't ask for a specific unit, but the units that they're giving you as part of your constants drive it. So your answer in this question is going to need to be in joules. Okay. Taylor?
Like, are the questions that you're showing right now, are those gonna be similar to the ones in the test then? Or are yours gonna be like different?
They're going to be different.
But like, are they like the same like concepts, like just like
So the difference between what I'm doing with these and what I have is because, so this is 2001's. This is the AP test from 2001, okay? The thing about the AP exam is that on the free response portion on the AP exam, they're covering an entire year's worth of AP chemistry in 7 questions. I'm covering 1 unit of AP chemistry in 3 or 4 questions. So these questions may seem a little scattershot because they're one bit or one piece of a series of questions.
Well,
Mine, I would be able to ask and have similar types of things, but more connected to each other. Does that make sense?
yeah, I was just like, because like, I was wondering if like the difficulty of like the test will be like similar to like the difficulty of these like problems or whatever, like or if the test is gonna be harder.
The difficulty lies in being able to recognize what you need to do. It's you know, having gone through the notes, having read through the chapter, doing all the things that I've had you do, you've been exposed to those things I can ask you to do. So the difficulty is making sure you can process all those little pieces. Okay? All right. Who's got this? Taylor.
Or 15. Oh wait, did I need to convert that into moles?
No.
Oh, okay. 15 times, 0.72. Times 39.7 minus 22.
Now what's that equal to? Where do we find,
I got 191.
I mean, what variable are we looking for?
Well, yeah.
That,
Sorry.
no, that's, so, did you have that as part of your setup, or did you just have those things?
I kinda just wrote that.
I'd be okay with that. I mean, but that's what we're using Q equals, and what'd you get for your answer?
I got 191.16, which does not have the right significant digits, but.
191 is okay. Subtracting those, is this 22?
It's 0.0.
So this is gonna have 3. Is this 7.72? Okay, so that's got 2, and this, after you subtract, is what you would use, and that's still gonna have 3. So technically, it should just be 190. Or, even better, like we taught you in first year chemistry, 1.9 times 10 to the second joules.
Do we have to do that on?
No. That's why this one's acceptable, right? Even though that's got one more significant digit than what we should have.
And that'd be acceptable on the AP test?
Yeah.
as well? Okay.
Yes. Putting 191 point, what was it, 191 point what?
1.6.
That would get you a point taken off possibly. Here's the thing, they pick a question that they go and look at for that. And they dot 1 point for the incorrect significant digits from the total points for all of that question would be. So if you had a question that all the parts added up to 10 points, and one of those questions was dealing with numbers, and they would look for the significant digits on that. If you didn't get the correct number of significant digits, you'd have a 9 out of 10 for that. Okay? Even though it's not wrong, they're gonna look for that someplace once. So you could have the correct number of significant digits in every other problem. If you got it wrong in that one, that's the one that, if you had it wrong in a different one that they didn't look at, you're fine. You don't know. Questions? I'm going to give you 3 minutes. Two of clubs. Who is it? No, I'm not gonna make you do a second one. 3 spades. Nope, not in this class. 5 clubs.
I said the maximum temperature would be the same.
Even if that were right, you wouldn't get any credit.
Because I didn't explain.
Exactly.
Okay, I explained, but I just.
Then why'd you stop?
I don't know.
So, read the full answer.
Okay, I said, although there's more iron, there's not more sand, which means no more mixture can be created than was created in the first experiment. This means that the same mass of mixture is used in the second experiment, so the same maximum temperature would be reached.
Agree or disagree? Why?
The temperature range would be greater as the specific heat capacity of iron is less than sand. Therefore, adding 2 moles of iron would make the heat capacity of the mixture lower, which in turn makes the required energy to raise the heat less.
Read your answer again.
The temperature range would be greater as the specific heat capacity of iron is less than sand. Therefore, like adding iron to make the overall heat capacity of the mixture lower.
But you don't have any information about the capacity for the sand. That's why I had to go back and look at what the question was earlier. I'm not gonna disagree with the answer is gonna be increase. How? This is okay. So let's see if this helps. I just don't have enough room. Who else said it increases? Why, Colin?
Greater because the heat capacity of iron is greater than sand, but more mass of iron means more heat to reach maximum temperature due to the enthalpy of iron, which results in more energy required to raise the kinetic energy to maximum.
Alright. You guys keep using the specific heat. The specific heat just simply tells you how much energy it's gonna require to change it. Okay? If you use twice as much iron, how much is the temperature gonna change? Lily? Twice as much. Why? Because you have twice as much, you have twice as much iron. The energy change is gonna be related to how much stuff you've got. If you change the amount of iron, you're gonna change the amount of energy changes taking place. We could ignore this question completely. We could ask letter C the same thing. So if this is the reaction that's taking place, and I use 15 grams, which is not 4 moles, right? But we know it's gonna give off energy because this is negative, it's an exothermic process. So we should see the temperature rise like we did over there, right? What we're doing is, that's calculating how much actual heat was released by that reaction by doing a calorimetry measurement. If we used 30 grams of iron, I mean, we could just plug it into this equation. If you use 30 grams of iron, what are you gonna do to that number? You're gonna make it bigger by 2 times. So, you're gonna get a higher temperature. You're gonna have twice as much energy. It may not be double the temperature, but you're gonna have twice as much energy released. So So letter B here said calculate the mass in iron in grams that react. Well, you'd use that energy that you calculated in A. You would use this information right here, and then you could calculate how much energy, how much energy was used. Yeah.
So like when you have to use that number, do you use 191.2 or the 1.9 to the?
So in letter C, if they asked you to calculate a new temperature, I guess you could do one of two things. You could either use 30 and calculate it, or knowing that would probably be the easiest way to do it. If you use 30, you'd have to use, and you're looking for a new temperature, you'd plug in 30 and you plug in twice this value. That'd be an awkward question to ask, though.
I was just like, for part B, it said to use like what you got from A, so would you use like the more specific number or like the sig fig number?
Oh, use whatever answer you got in the previous question.
Okay.
So like, if this is the answer you're reporting for your answer for A, then B is gonna use that. So B would, in that case, would be that times your, calculate the mass. So you use that, then you have to use this negative 1650, okay? And that would be to 4 moles of iron. Because in that balanced equation, there's 4 irons for that energy. Then you just do your mole to gram. Okay. The temperature's gonna be higher because you used more iron. You're simply gonna release more energy because you had more iron.
If you double the mass, and you said then you would double,
You double the energy, but not the temperature.
but if both sides are double, then the temperature wouldn't change.
But if you double the amount, so this is saying you had the same amount of sand as the first experiment. So the sand is what the energy is transferring into. Okay? So you got a hand warmer. Like I said, looking at this, they made it hard now because they used to have, the questions were all on one page, and then you had line pages that you would answer your questions on. Now they have the question and they give you space to answer it. So you got a hand warmer based on this reaction. That hand warmer is made by using iron, by using the sand and a catalyst. If you double the amount of iron in there, you double the amount of reaction that can take place, which means you're gonna double the amount of energy that's gonna be released. If that hand warmer is the same in both instances, except for the amount of iron, the one with more iron is gonna have a big, larger temperature change because you've got more iron there to react. Does that make sense? Questions? That's standard conditions. STP would be 0 Celsius. Are you asking because of the 22.4 value? Yeah, you wouldn't be able to use that value. Just got an answer, or at least can tell us what we need to do to get an answer. Steiner?
Read my answer. 1.31.
Tell me what you set up.
0.325 moles of O2. Times 32 grams. Divided by 7.95 liters.
What'd you get?
10.4 grams. That's the moles. And then final answer was 1.31.
How much was the final answer?
1.31.
Agreed? Okay. Nessa?
Would that change if it was like 20 degrees and like 1.21 ATM, the previous question? If it wasn't like standard
No.
temperature
Temperature's not gonna change this. Because the density is measured solely on how many grams you have in that volume. Okay? When I return, somebody has to answer. 7 clubs.
Okay, that's me. Okay, cool. So, I said that water begins to evaporate when its temperature gets close to boiling, so that's probably why volume is lost, because it turned into gas and then it's just left.
Let's draw more cards.
10 diamonds. Not in, yeah. Nope. 4 hearts.
I said that since O2 is a real gas, it does not correct all the way follow the rules of the ideal gas. For example, there are going to be intermolecular forces between the particles, and the gas particles themselves will have a volume. So, whereas in ideal gases, they do not have volume. So the volume would be a little bit smaller than the calculated volume.
Nice shotgun approach. You threw everything at it dealing with the intermolecular forces, the size of the molecules and stuff. The problem is that shotgun approach has too much stuff. Pick one of those 2 factors. Which one do you think is going to be the primary reason for why the volume is smaller than you calculate?
The volume
All right, you picked the wrong one. Okay, now so you said that, Anubhav, you said that the real gases have what?
they have volume and molecular forces between.
Okay. So if they have volume, that would mean that your volume that you calculate would be too small. This, we're saying the volume you calculate is too big. Okay, so you measure the volume being smaller than what you calculate. So let's go with the other one. Why would the intermolecular forces make it smaller than what it should be?
The intermolecular forces would have more collisions, so there would be less collisions.
No,
Less collisions?
no. Alright.
Is it when the molecules are moving slower that the intermolecular forces play a larger part, so then the measured pressure is lower than, or the actual pressure is lower than what you calculate or measure it as, because the intermolecular forces,
You're right.
which
Nothing you said's wrong. But what's the question asking about though?
if the pressure, if the actual pressure is lower than the, it's asking about volume, I'm trying to relate it, the pressure to volume. They're
You
inverted
can.
equally.
I'm just saying if you can. I'm saying if you can.
Okay, so the actual pressure is less than what the measured pressure is, so that means the actual volume is more than.
But the actual volume is small. Go.
When you use the ideal gas law, you assume that there's no intermolecular forces, but there are, so they're more compact.
When you say more compact, what do you mean?
They're attracting to each other, so they get closer.
That's the key. Your intermolecular forces are gonna pull them closer together. And that's what's gonna make the volume smaller than what you calculated. One of the keys here is this: the boiling point of oxygen is -183, and you're at -180. You're real close to turning it into a what? A liquid. Okay? That's a tough one. Okay? That's a tough one. Other questions? Okay, there's a lot going on here because this is what they used to look like. You get all the questions and you get a separate page to answer them on. By the way, go back to this just because, and we'll talk more about this at the end of the year. So if this is an 8.5, 11 by 11 piece of paper, the work that Steiner told us fits in there. That's a lot of room for it, right? One thing to keep in mind is that how much space they give you is probably a lot bigger than the amount of space you need to use. I say this for when you have to write written explanations. Your goal is to do not to fill the space, which is what your English teachers have trained you to do. Your goal is to answer the question and get the hell out, okay? And do that in as few words as you possibly can, right? This is not essay time. This is answer it, get out, okay? So, all these questions here related to this, I want to focus on the G, okay? So, calculate bond energy. This is also called bond enthalpy. The bromine-chlorine bond, and you have this information to go with. Because this is dealing with bonds, I will give you this information. How'd you set it up?
So I set it up with the equation that we have, which is the delta H equals the summation of the products minus, wait no, it's reactions minus products, so that is wrong, but it's okay. So it would be 2 BRCO minus 193 plus 243.
Say that again.
So 2 BRCO or X, whatever you want your variable to be, minus the bond energy for your bromine, which would be 193, plus your bond energy for chlorine, which is 243.
243?
Yeah.
What's that equal to? You're missing a number.
Am I? Oh, yeah, 1.6, yeah.
Now, class, the way that Lily set that up is using the equation I gave you last time in class. That equation is not on the AP exam. If you look at, or on the reference page. This is one that you're gonna have to just know off the top of your head. And like Lily, you made that mistake initially, it is the opposite of what are on the page. It is the only one we will ever do that is reactant minus product. And that's because of how the numbers are given to you. The numbers for bond energy or bond entropy are always positive values when they are presented to you. Now, you can change the sign accordingly, okay? The alternate way of doing this would be to say 2x plus negative 193 plus negative 243 is going to equal your 1.6. That's the alternative way of doing it, which is just using the equation as is. Or you could use this equation. I don't care. Remember the rules, right? I don't care. Get it right. Show me work. Don't cheat. Okay? Questions? You've got did I see some more people finish these up while I was doing class today? I'm cool with that. It doesn't bother me a single bit. And we've got these. I open this one back up. Don't forget to go, if you've done it, don't go back, don't forget to go back in and score it up, okay? Do these. These are the multiple choice. They don't take as long, okay? These are your multiple choice. Do them. These are free response. The nice thing about them is that they have the questions, and then you can submit it, the entire thing empty, and go and look at what the answers are. I don't care. It's a tool for you to use. Okay? Really, the only thing you need next time is a pencil. I will be supplying the calculators for use on the multiple choice. If you haven't trusted any further, I can throw you. Sorry. Don't take it personally. It's just business.
Oh, I did.
Oh, I can't remember. Like this, like you know, a paper.
What?
I told you.
Can I come in tomorrow morning to ask you a question? Because I don't understand like the solder one.
That was gonna invite you.
It's like, I think it's either 4.7.
Don't forget, you got A. Fill out the form if you want to come in here and A. Here's what we're going to be talking about. Getting a solution.
Oh my god, he told me, I was like, what is that?
In the second semester, that falls into the section on the intellectual forces better than this year. And that's the one thing about these is that you get overlap. Because these are questions that are designed to be used on the AP exam. So you're going to have some overlap there with topics you may not know. It's not because it has overlap, it's because the questions, they're not the best designed questions in the world. When it was first made, I can't remember how many years ago, it was a decent one because the type of questions that were asked on the AP exam were different than what they were asking now. They're much more, it's much less rote memorization. It's much more interpretation than the questions. So that's what the algorithms, they lack some of that. Okay?
I'm having like a problem, man, like, show like 6-7 days after you reach
Do you have your own device or do you have?
I use my own device and my screen.
I don't know, nobody else has said that they're not going to
You saw me running. Whole dead sprint.
I don't know. I really don't.
It's also so cold.
We call it here.
Mahindra, send me an email and I will reply
It
to
would be
it.
really nice.
Yeah.
My stuff said, it was like,
Is it a lot?
it was like 6.
Is it locked? Okay.
Each of them are like 3 problems, but still.
Send me an email. That's something I'll do on.
How did you get a bracelet?
I don't think
Yeah.
you have any owls.
This guy in my last class.
Except for the-
3 of them.
He's gone.
Where'd he go? I was like, sure.
He left. I tried to go to the bathroom or something.
Is this a bag?
I got all my stuff.
I brought
It's not?
I brought
I didn't get to
goggles.
show you. I don't know.
It's not.
They really left us.
Yes.
You ready to go swimming?
Yeah.
You ready to swim?
You're not in my
No, I just got it. You could have given me the ensemble.
Are you telling me this
But
now?
I don't know what teams figured out. One. Because they obviously already surround. They don't have, they don't have something.
That's okay. Someone
Yes.
left their hairbrush.
Huh?
Someone left their hairbrush.
It's not mine.
Yeah, I assume it's not.
Look at these flowers, they're so different than any other ones.
Yeah, it's like actually like semi-formal.
Definitely blonde.
It's you.
It's not mine.
Also,
Spirit.
guess who matches one of them to draw the first flower?
You're in.
Sure.
Oh.
She gave me the papers and I was like,
Like, is there like 3 other art projects?
I told her,
Where's the artist in the group?
I told her like that we had a class together and she's like, oh, perfect.
They made it so complicated, and then they're like, okay, here, do it. And I was like,
Have you restarted?
like, ornament symbols, and it's like a center part.
When we're short.
Yes. And I was like,
Oh yeah, wait, it's Wednesday. I'm supposed to be here.
Yeah. You get a good cheer.
I'm glad my star was in the parkway. So I started like walking there and like I got into the hall of excellence to like keep walking. I realized I'm like, oh I gotta turn around.
Send me that email. What's that?
Yeah, imagine if I did realize till I got to the side. I had to walk all the way back. Forget these things. Not good. Looks like we're just doing this.
I mean,
I would agree.
I literally didn't
Yeah, you checked them very quick.
No, the notification pops up.
Oh, you are here. What's that?
The only thing I can tell you is to check.
Over here.
How do you have
Yeah, I see how.
Me and Andrew thought you just left us.
Oh, no, I would never do that.
that, or every day at a specified time, check email and get rid of the 3,000 that you have not read. Because by now they're probably irrelevant.
Practice problems. Pretty easy.
Are they Canvas messages? Are they Canvas messages?
No, they're just spam emails. They usually post them on the It was like an unsubscribe or whatever.
I think I brought it to the doctor. I said it down.
What?
Yeah, I've probably got like 60.
You bring it to use the bathroom and you like fill it up or something?
Holy
Did
cow.
you leave it there? Well, where is it? It's probably in the bathroom.
No, because I came back in the same room.
Did you?
Yeah.
Stender, did you?
I did, yeah. I came back in. Did you? Yes, did you take it?
Oh, Steiner,
Oh.
go ahead, stop the line. Phone, please.
On what?
On my
Oh,
phone.
yes, okay.